Hey guys, welcome back to the channel. In today's video, I'm going to be showing you guys how to create an app and track the gamma exposure for a single stock or ETF. And for this example, I'm just going to be using one expiration, and this is the actual output. So we have two plots. The plot on the left tracks the gamma exposure and prints out the flip price along with the current price, while the chart on the right keeps track of the minute changes for the gamma exposure profile, and it's a summary in 1 minute intervals for the plot on the left. So if we go all the way to the right, we see that we have 4 lines. We keep track of the flip price, which is this gray line, and as you see, the level is 515.38, which matches the chart on the left. SPY at the time of the run was 510.16, which is currently displayed here as well. Now the green and red lines plot the highest levels of the curve. So here we see that that level is 520 and the lowest is around 507, and if we go here, the actual highest and lowest was 520 and 506. So there's a couple of files that are involved in tracking this using 1 minute intervals, and as long as you're able to get a quote for the option that has some of the Greeks, the implied volatility, and open interest, you should be able to run this app. Now the final thing is this scroll bar. So we're able to plot up to 390 bars since these are 1 minute intervals, but if you want to zoom in on the chart, you could just set this to the number of bars that you want to display. Here we'll scroll all the way to 10 and it's going to display the last 10 bars. Every time you change this, it'll go ahead and grab the latest observations for the gamma exposure profiles, and I'll show you how that works from our scripts. So let's go ahead and close this out and take a look at our scripts. To run the app, we're going to need these two files. This third file, called GEX fun, has all the functions needed to make the calculations for the gamma exposure profiles, along with helper functions and some wrappers to collect data. And in this particular example, I'm using TD Ameritrade, so I'm not going to go over those functions since it'll be deprecated. So you can replace those functions if you have your own data provider. And then lastly, we have this file called GEX loop, and the sole purpose of this file is to iterate every minute and grab the latest gamma exposure profiles based off of the option data we have collected. So for the first two files, it's relatively simple. You just want to copy it the way I have. And in the second, called server R, we're going to require some packages. We're going to source all of our helper functions to make calculations. And in our main function here, it's going to take an input, and I have these two helper functions which extract the gamma exposures needed for both of the plots. Every time the user updates or scrolls on the number of bars, it's going to grab the latest files. It's going to subset our minute intervals to the last number of bars that the user scrolls on. So that's all that's happening here. It's just grabbing the latest files and creating both of these plots using high charts. And I use HW grid to display these charts side by side. So this is all that's needed for the actual app. Now for all of our helper functions, we have quite a few things. So this first chunk loads all the packages, sets our working directory. I have assigned my API key for TD Ameritrade along with the refresher token that goes along with that. So if you have access to Schwab, just replace those functions pertaining to the TD Ameritrade API. If you want to use your own data provider, you won't need to assign your API key most likely, or refresher token. Now the next chunk just assigns the ticker symbol and the option expiration date, which you can do here, but we can also modify these in the GEX loop. We also get the risk-free rate needed to calculate option pricing. So we're going to take that rate, divide by 100, and then by 360 to get the daily rate. Now the following two functions pertain to the TD Ameritrade API. So in this first one, I just pass in the strikes, the expiration, the underlying symbol, and the option type to create the option symbol string in TD Ameritrade format. So you might not even need this if you're using your own data provider. The next one just gets the quote for that particular option. So I'm not going to go over that since this will most likely be deprecated. Since this quote function grabs several columns, I'm just going to trim that table down. So if you're using your own data, these are some of the columns that are needed to run the app. So it's going to grab the table we got from TD Ameritrade and trim it down to only these columns. Now, once we calculate our gamma exposure, we want to convert the files that we got into an XDS object to plot it in our app. So in the loop, it's going to make the calculations and save these as RDS files every minute. So I'm going to read all those files in. I'm going to extract the max level, the min level, the flip price, the underlying price, and then the current timestamp, and just convert each of those files into an XDS object, which is what we will be returning. Now to go along with it, we also need to extract the latest GEX table. And again, similarly to the line above, we're going to list all of our files and return the latest one. I also have a function that pauses between intervals. So we're just going to pass in a timestamp, and we're going to sleep a certain number of seconds depending if the attribute or the time difference between our current time and the bar time is in days, hours, minutes, or seconds. So this is just a helper function needed in the GEX loop. Now the next two functions also pertain to the TD Ameritrade API, so I'm not going to go over these as these will be deprecated, and if you're using your own data feed, you probably won't need them. And this last function takes in the underlying symbol and the expiration date and makes the calculations for the gamma exposure profile. So if we open this up, up, we're going to start off by getting a quote for the underlying symbol. It's going to return it as an integer, and then I'll subtract 50 points and add 50 and create a sequence to make a range for the strikes. It's going to take in our expiration date, which should be this one that we pass in, and it's going to convert it in this format so that we're able to build our option symbols in the same format TD Ameritrade has. So depending on the symbology, you might need to switch this around in order to build the option symbols depending on your data feed. So we'll do that for the calls and the puts and convert these into a single string, which we will pass in this get quote function, one for the calls and one for the puts. We're going to trim our table down using our helper function. To speed things up, I'm going to remove all options that have zero open interest. Now from here, it's going to extract the underlying close from our quote table, and in order to calculate the gamma exposure, we need to assign a range for the underlying stock. So I'm going to take the underlying close at the time of the run, I'm going to subtract 10 points and add 10 points and create a sequence for the theoretical underlying price, and then we can start calculating the gamma exposure for the calls and the puts. So for the calls, I'm going to take each row which represents a different option, and for each of the options we're going to pass in our stock range and calculate the theoretical option price for each value in my stock range. And of course we need to pass in the implied volatility, the risk-free rate, and the expiration in years. And for the calls, it's important to place the direction as 1 or positive 1, and for the puts it'll be a negative 1. Once I get those values for all of the options, I'm going to row bind my results, and then I'm going to reframe the table or summarize it to get the call gamma using this calculation. And it's essentially the same for the puts. All that really changes, I believe, are these two variables. So instead of calls, just replace those with puts, and then the direction will be negative 1. And again, we need to summarize to get our put gamma. Once we have call and put gamma, we're going to combine the two, and then we're going to make some calculations to extract the flip price, which will essentially be where the total gamma flips from negative to positive. And I have a few checks here in case the gamma exposure is fairly choppy, which tends to occur if you have multiple expirations. And again, we need to find the point of intersection, so you can just copy this function. Once you have made those calculations, we're going to create a table and add a few extra columns needed to run the app. So the final output of all gamma should look something like this, where we have our theoretical underlying close, the call gamma, the put gamma, the total gamma, and then the columns we added. So we have the flip price, the expiration date, the underlying symbol, the underlying price, and then the timestamp of the run. So each minute it'll calculate and return this table and save it in an RDS file in our working directory in a folder called intraday GEX. So just change this or add that folder into your working directory. And that's all that's required here for this particular file. Now in our GEX loop, we're going to set our working directory. We're going to source all of our functions. I'm going to change the time zone here so that it lines up with New York time. I'm going to assign the start and end times of when we should start and end collecting all this data. So I want it from the market open until the close. And then by using those timestamps, we're going to create a sequence of times 1 minute apart. In case it crashes and you need to rerun, I have inserted line 12, which will get rid of the old timestamps and make sure we pick up at the very next bar. We're going to use our helper function to pause for the next timestamp available in times, and then it'll begin the loop. So here's where you can change the underlying symbol and expiration dates depending on the symbol you want to extract. And after we make that calculation, it'll pause for the next bar. So it'll continue until it exhausts all of our timestamps. So in order to get things started, you could always schedule this, or you could run it as a background job, or you could even run the script in a separate R session. Once it's started, you can go ahead and run the app by going to this UI.R file and then click on run app. And that's pretty much all you need to get this working. And with that, guys, this concludes the video. I hope this was useful information. I'll leave a link down in the description area to my Patreon where you can find this script. Please consider subscribing to the channel if you haven't done so already. Thank you so much for watching, and I'll see you guys in the next video.